everybody. We are going to learn today how to transform parent functions. This is a new topic and we are going to go over it next class. So let's get started. But I'm going to split it into two videos because I don't want it to be one really long video. So we are going to be moving and morphing graphs of parent functions. That's not a question, that is a statement. So what is a parent function? A parent function is the most basic of each type of function. What does that mean? It is literally the most basic of each function. So let me give you an example. So the linear function, we know what a linear function is, right? Like a line. And the parent function of a linear function is y equals x. That is the most basic of a linear function. Slope is 1, y-intercept is 0. Y equals x. A linear function has a degree of 1. That is how we know it is linear. It has an x and it has just an x. No x squared, no x cubed, no square root, just an x. Now, it is called a parent function because that is what we are going to be moving, okay? Every function is basically a transformed parent function. So it is a result of the parent, okay? So we are not going to talk about transforming linear functions because we already know how to graph and move linear functions, but we're going to learn first about quadratic functions. So I know we don't remember a lot of the properties of quadratic functions. We're going to do a little bit of review today. This is not an in-depth review of quadratics. This is simply moving a parent function. That is it. We are doing quadratics later on a different unit, but this is simply just transformations. So what do transformations of a quadratic function look like? So the parent function of a quadratic is y equals x squared. Again, it is the most basic. In order for something to be quadratic, it has to be to the second degree. Has to be. 100% cannot be quadratic if it doesn't have a squared in it. That is the literal definition of a quadratic function. It has to be to the second degree. Okay, so the most basic of quadratic is just x squared. Okay, so this is what y equals x squared is. It's 0, 0, right? 1, 1, because 1 squared is 1. 2, 4, 2 squared is 4. 0, 0. And then we have negative 1. Negative 1 squared is 1. And then we have negative 2, 4. And if we keep going, we would get 3, 9, because 3 squared is 9. And then negative 3, 9, because negative 3 squared is 9. This is the parent function. I'm going to keep saying it so you don't forget it. The parent function is y equals x squared for quadratics. Okay? So we're going to look at Desmos today. We're going to look at what it looks like to transform a function. So this is absolute value, which we're going to do in the next video. So quadratic function transformation. So I already have this graph here, right? Y equals x squared. What happens if we add a number to the end of it, right? So x squared plus 5, x squared plus a number. So this little slider right here is going to tell us what the number is going to be. So let's say we move this up to 1, right? Well, what happened to the function? We have x squared plus 1. What happened? It went up 1, right? And as this number gets bigger, the function gets higher and higher to the point where we can't see it, but it's up there. So what happens as we add a number to the end of it? Well, we move it up. Well, what happens if we subtract a number, right? What if it was x squared minus 5? Well, then it moved down 5 units. If you notice, it went from 0, 0 as our vertex to 0, negative 5. Okay, so we know that that k on the end, it moves it up and down. Okay, what about the next one? What about if we have a number on the inside? So this is where things get a little bit weird. Notice how here the k is directly affecting the entire function, right? X squared plus k. X squared is our parent, then we just add k onto the end. Here, we're not adding or subtracting h to x squared. No. We are adding or subtracting h from x directly. Notice that squared is on the outside. It's like we took that x, we put parentheses around it, and then we stuck an h inside of it, okay? It is directly affecting the x, okay? You gotta remember that. If something is directly affecting the x, it is going to move along the x-axis, meaning it is going to be horizontal. Let's look at that. So if I move this up, look, it's moving to the right and to the left. Okay, versus this was affecting the entire function, so it was moving up and down, so it is vertical. Okay, so now this k is a vertical shift, this is a horizontal shift, but I want you guys to notice something. If I have plus h and I have x plus 1 squared, let's put that 1 there. You would think, right, oh, up here, 1, if it was 1, it went up, and if it was negative 1, it went down. You would think positive 1, x plus 1 squared, would move it to the right one, but no. When it directly affects the x, it goes in the opposite direction. The way that I always like to think about it is, this is your x, right? When it's affecting your x, you think about like an ex, boyfriend or girlfriend or whatever, right? If you have an ex, they usually do the opposite of what you want them to do. So you think about when it's affecting the x, it's doing the opposite of what you want it to do. So if I have x plus 5, it is going to the left 5. If I have x minus, let's say, I don't know what, hold on. Move. If I have x minus 2, it goes to the right 2. If I have x minus 9, it goes to the right 9. So it goes in the opposite direction. Okay? So let's try another one. Or let's see. So we have k, but it's at the end, it goes up and down. H, when it's inside, it goes right and left, but it goes the opposite of the sign that you think it's going to go. Okay. What happens if I have a coefficient in front of the x squared? Let's see. So when it's just x squared, the coefficient is 1, right? Any variable by itself, the coefficient is 1. If I move this and that number gets bigger and bigger and bigger, what happens? The parabola gets skinnier and skinnier and skinnier, or steeper, right? It's growing at a quicker rate, which is true. It is growing at a quicker rate because it's being multiplied by a number. Now, what happens as it gets less than 1? So here we're at 1. When it gets less than 1, it gets stretched out. Okay? So we're going to write this all out as a recap. But I just want you guys to see what's happening. So as it gets bigger and bigger and bigger, the parabola gets skinnier. It's growing at a steeper rate. This is called a vertical stretch. The reason it's called a vertical stretch, and look at me, when you think of Play-Doh, right? If I have Play-Doh and I stretch it out, right? Vertically, it gets skinnier and skinnier and skinnier, right? Versus a vertical shrink, right? If I take Play-Doh and I squash it vertically, it's gonna get fatter. So when A is a number that's less than 1 and greater than 0, between 1 and 0, it gets squashed. So it's a vertical shrink. Okay, so it's vertically shrinking. Okay, and then lastly, we have one more transformation that we're going to talk about with quadratics, which is if there is a negative coefficient. And so for that negative coefficient, what's going to happen? It is literally going to turn all of our values negative, which means it's flipping. It's a vertical reflection, meaning it's flipping over the x-axis. If it's flipping vertically, right, up to down, it's going to flip over the x-axis. So those are our 4 transformations. So let's go back and define them again. So we have K, which was our first one. It moves it up and down. This is called a vertical shift. Then we had H. This moved it right and left, but it went the opposite of what you think it's going to go. Again, if it's x minus 2, it's going to go to the right. And then this is called a horizontal shift. Now, we have this reflection. This we're not going to worry about right now. We're going to address this at a later time. But this is what we went over, is that if it's negative, it's a vertical reflection. So this, it flips over the x-axis. It is always going to be concave down if there's a negative a value, which means that it's going to be an upside down parabola. And then a dilation if you have an a value. So here's what you got to make sure you write down. So it is a vertical stretch, right? Vertical stretch, skinnier, if x is greater than 1 or a is greater than 1. And then it is a vertical shrink, right? Which means it's wider if a is between 0 and 1. Obviously, we can't say if the negative makes it flip. Now, here's what's important. Let's go to Desmos. If I have an a value, let's say y equals negative 2x squared, notice, or let's do a larger number just so it's clear. It flipped and it was vertically stretched because the negative flips it, the 10 stretches it. There are 2 different types of transformations. Now, what happens if I add 4? Where's it going to go? Up 4, right? If I add 4 to the end, it's going to go up 4. If I subtract 2 to the end, it's going to go down 2. If I go inside of this x and I add 3, where am I going to go? To the left. Remember, plus 3 does the opposite of what you think it's going to do when it's affecting the x. Okay, so let's practice graphing a few of these. So if I have x squared minus 3. Now, our parent function always looks like this, right? It is 0, 0. Hold on. I have 0, 0, right? And then it goes 1, 1, up 1 over 1, and then 2, 4. So we have 1, 1, 2, 4, 3, 9, right? We know that that's how it goes. So that's how we're going to graph them. If there is no number in front of here, there's no 2, 3, 4, 1/2, that pattern doesn't change. We have 1, 1, 2, 4, 3, 9. When we have a number in front, then that changes it. We have to multiply this by that number. So we're not going to worry about that right now. First, we're going to do y equals x squared minus 3. X squared minus 3 is this function, the parent function, but it is moved down. I'm actually going to draw the parent function really quickly. 2, 4, just a quick one. Boom, 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 boom. Just so we can compare. And then we have to do -3. 1, 2, 3. It's going down 3, 1, 1, 2, 1, 2, 3, 4. And I'm going to even do 3, 9. So this was 4, 5, 6, 7, 8, 9. And then I can just reflect them all. Keep in mind, a parabola is always symmetrical. So here's my parabola. Make sure it looks round. It doesn't look sloppy. There it is. Let's try the next one. So we have y equals x minus 2 squared. So I know, so this one, it went down 3. This one is going to go right and left because it's affecting the x. It's going horizontal. So I'm going to go not to the left, even though it seems like it would be left. It's going to go to the right 2. It's going the opposite of what you think it's going to do. So I'm going to do my parent function again. Oh, that's a line. 2 and 4, reflect it. Okay, so we have right 2. So I'm going to go literally take my vertex, and I'm moving it to the right 2, and then I just put my points. 1, 1, 2, 4, and there's my parabola. Okay, last one for parabolas. Okay, now this has 3 different transformations. Here, it is going up 4. That is my k value. Here, it is going to the left 1, left. And then this is a reflection. Reflect over the x-axis, so it is concave down. So I'm going to move my vertex first. So here's my parent function. And so here's my vertex, right? I'm going to move the entire parabola. It's going to the left 1, and it's going up 4. 1, 2, 3, 4. Here's my new vertex. If you remember, this is in vertex form, which means that the vertex is the opposite of this and the regular of this. So my vertex is going to be -1, 4, which is what we get here. But I'm not going to go right 1, up 1, because I have to make it concave down. So instead of going up, I'm going to go down. So I'm going to go right 1, down 1, right 2, down 4. And then reflect it over the vertex. And there is my parabola. You always graph to the end of the graph, because that communicates that it goes on forever. So this is transforming parabolas. I'm going to post a video on transforming absolute value functions next.